All right, so we're going to hit. If your computer's working and it's ready, follow me. If not, watch. You can do this in a second. You're going to hit this orange button here that says Play with Simulations. Now, on the left side, we're going to click Physics. We're going to scroll down. Now, it's very important the next thing you do correctly. There are two labs that look identical. See them? They look identical. We're not using Basics. We're using this one over here on the left, Energy Skate Park. If you try Basics, it's not going to be able to do the things you want it to do. Okay? You're going to see in your lab, I'm going to ask you to do a bunch of stuff. Only works with this one. So we're going to click on Energy Skate Park, and then click Run Now. Everybody see Run Now? It's going to launch a Java app which will run. Now, my computer is not going to launch right away. It's going to ask me to save it when I do that. Okay? Second?
It's an action script app.
I can't hear you.
It's an action script app. Java's just the click a button.
Is that how it works? I don't even know. It uses Java to load. That's all I know. See?
But it's emulating everything.
Emulator?
I don't know why they do that, but
I don't know.
Wait, so it saves time for sending? Yeah, it's like save like uploading stuff, but really it's just trying to load.
I don't know.
You know Stocks writes code.
I do. We were talking about the other day. All right, now, take a look.
it does so I can open it in one state.
Several things. First, under part 3 it says, click pause. Click pause. So just to give you a little overview, you can make this, make the actual person go slower and faster. So that's slow, that's like medium, and then here's fast. Now, pause stops him along the way. You're going to have to use the pause button on the line, down at the bottom. On the right-hand side, you're going to see potential energy reference line. See this? Everybody see this right here? I'm hovering over. I'm going to click on this. See the blue line appear at the bottom? Watch the bottom. Right here, the blue line is going to appear. Now, that tells me that that's ground level. If you want potential energy to be 0 at the bottom of the ramp, you need to take this line and drag it up, which you're going to have to do. So you take the line and drag it up like this. So now what the program knows is the following. The program thinks of this as the ground now. So at the bottom of the ramp, it'll be like it's at the ground level, so there'll be no potential energy at the bottom here. Again, so we take that line and slide it upward. Now, after that, it's going to say click Return Skater and resume, and then watch the bar graph. Now, you're not going to see bar graphs right away until you click on energy. So here, on the right-hand side, you're going to see bar graph right here. I'm hovering over it. I'm pointing to it right here, bar graph. When you click on bar graph, you're going to see an energy graph load. What I'm going to do to make it easier to see is put it on the side over here. And we're going to see there are different types of energy for this bar graph. We see there is kinetic, potential, then there's the total energy of the system, and then there's what's called thermal energy. So think about it for a quick second. This person, at this point in time right here, has some height. And this person was moving a second ago. So at this point in time, the person has both potential and kinetic. So that's why they're both lit up. And it also has a total amount of energy, which we're going to see is the sum of these two. There is no friction involved in the process right now, so friction or thermal will not change just yet. Now watch what happens. When I hit play, we're going to see the energies changing. You see the balance. Watch, right at the bottom. What is it mostly all? Kinetic, because at the bottom, the person is mainly moving with no height. But the person has a little bit of height, right? So look, isn't there a little bit of potential there? Now, at the very top of his or her path, when I pause it, look at the kinetic energy now. The kinetic energy is almost non-existent, because when the person or object gets to the top, he or she stops instantaneously, and then starts coming back down. So you'll notice it's almost all potential. And look, the total energy should be almost the same as potential right now. Almost, right? Because there is a little bit of kinetic. If you take the little green bar graph from potential, or kinetic, and the blue one from potential and add them up, you will get this total right here. And there's a way to read out those numbers in a minute. Okay? Now, phet.colorado.edu. I'll write it on the board.
And then can you go over how to go there and just upload?
Play with Sims. On the left side, you're going to see physics as a choice. You're going to scroll down and go to Energy Skate Park. Yes, Tom.
How do you reset it to like standard?
You could just hit reset up here. to the very top. Okay? So again, for those that are just joining, that are just loading right now, what we've done is the following. We paused the runner, first of all, the skater. We clicked on potential energy reference, this line right here, which bordered this blue line. It was at the bottom. We moved it up so that it was lined up at the bottom of the ramp, so we consider the bottom of the ramp 0 potential energy. Okay? This is like the 0 height now. I mean, you could have also, just so you know, don't do this, please, but you could have also done this. You can take the ramp and actually move it. Okay? So you can move the ramp up here, and then if you hit play, the guy's just going to fall. Or not. Yeah, he'll just fall there, okay? So I'm going to reset it so we go back to the beginning for that. Okay, I'm going to turn my potential energy line on again. I'm going to take my potential energy line. I'm going to grab the line, move it up. Now look, notice, you can't move this potential energy line unless the hand appears. Watch, on this side, see how there's the hand it appears? There's an arrow. I can't move the potential energy. When the hand appears, it means you have a grip on it. You can then move it. Okay? Now, we turn on our bar graph right here on the right. It puts the bar graph up. If you don't see the bar graph, it might be behind the other window. In case you might have to move your windows around a little bit. Then we're going to hit play and watch how the energy changes as a function of the person's height. So at max height, all potential, all kinetic, all potential, all kinetic, all potential, and so forth and so on. Okay, that's the beginning of what we're going to do. There's questions for you to answer along the way, but I'm trying to step you through the procedure. Next, even though if you're not done, flip over to the second page. I know you haven't answered them yet, that's fine. Flip over to the second page where it says add friction at the top. So you're going to pause. Then on the bottom right, click on track friction. You'll see it on the bottom right here. It says track friction. Now, you're going to see there's a little bar that appears, and it says coefficient of friction. Remember the mu value we've been talking about? You can take the mu value and you can alter it. So if you want to take the mu value and increase it or decrease it, you can do that. I would put it maybe like a quarter of the way up for now. It doesn't matter. Okay, approximately a quarter of the way up. Now I think I told you exactly where to put it. It said change it from none to the next mark. Okay, if you scroll down, watch what's going to happen here. There's little marks on this screen. You can barely see it on my screen. But on your computer screen, you're going to see little tick marks along the bottom. Move this little cursor so it's right here. I'm pointing on my screen right now if you want to look. There's a little tick mark right there. Okay, so the first one over. So this is going to go to right here. Okay, the first tick mark. Okay, the first tick mark. Now, once you've done that, you're going to click return skater and resume. So you're going to continue moving. And watch what's going to happen now. I'm assuming that some of you can predict that, obviously. But as this happens, we're going to lose energy to friction. So what's the person going to do? Yeah, he's going to go slower and slower. So watch what happens. Look at thermal energy, everybody. Look. Look at the thermal energy. It keeps rising because he's losing energy to heat. He's slowing down more and more. He's slowing down more and more and so forth. Until what's going to happen eventually? Yeah, he's going to eventually just stop. Okay? So once the thermal energy reaches the total energy, it means that we've lost all of our energy to heat. So once this red bar matches up with the yellow bar, the person's going to stop moving. Look at him. He's now just perturbating back and forth. Perturbation means slight movement or slight change. Okay? He's oscillating is a better word. Oscillating back and forth like a spring oscillates. Okay? So look, he's moving back and forth, back and forth. Now what happened? What happened to him? He stopped. Take a look at my bars over here on the left. Everybody see this? What do you notice? The thermal energy and the total energy are the same. Because all the total energy that he or she had to start in the beginning of the problem has been lost to thermal energy. And that's what causes you to stop. Okay? Next section. I'm doing this for a reason, guys. You're going to answer these questions on your own, but I'm going through the procedure because it's a little confusing. The next section says investigate gravity. So, click the reset button. So let's do that.
Wait, does the mass of the skater matter? Like if I were to say change it to a dog on a skateboard?
We're going to do that later, so hold off.
Okay.
So let's hit reset, everybody. Then we're going to hit yes. Okay, so this guy's going to be floating back and forth again. On the right, find the location. Everybody see the locations here? Change it to the moon. So click on moon. Whoa. Say again?
Whoa. Whoa.
7 and 8, you're going to work on your own. 7 and 8, you're going to work on your own there. I was just setting you up there, yeah. So what happened is this. Look, he was on Earth. The person was on Earth. We hit reset. We hit yes, right? Now watch. The minute I hit moon, he's going to fly right off the ramp. Because what happens on the moon? There's less what?
Gravity.
There's less gravity. Very good, Dan. So he's going to shoot off. Now watch. Here returns Skater. And he's going to come back to the moon. All right? So now we're on the moon.
Wait, mine didn't fly off.
Why do you think he's going slower? There's less gravity. Remember, gravity is what accelerates you down and up, down to the Earth, right? Or down to the moon. If there's less gravity, this person is going to pick up less speed. It's going real slow, all right? Now, here's what I'd like you to do. I can let you guys do the rest and stop. I know you're talking to each other sometimes, but please listen. 1.62. 1.62, that's like 9.81. Now, notice the units in this program happen to be different. So I made sure to ask you, what are the units and what is this the same as that we use? Okay? What I want you to do is judge the relative speed. So you're going to have 3 choices for Earth, Moon, and Jupiter. One's going to be fast, medium, and slow. So look at all 3 scenarios and see which one is the fastest, the slowest, and which one is the medium. And try and make a correlation you'll see to the gravity. All right, next, investigate mass.
Wait, excuse me.
Yes, Molly.
Sorry. It gives us the gravity.
Correct. You're just going to write it down, that's it.
And then
So when I change this to Earth,
the speed you say medium, fast, or...
mm-hmm,
Okay.
we're not going to use outer space. Why are we going to use outer space, people? There's no... Yeah, there is no gravity. This guy's it's never going to work. Watch. If I get him going, if I just drop him down like that, which I can't even do.
You can give him a rocket ship.
Where's the rocket ship?
Just the arrow.
No, that's a cheat. Cheating.
Ah, okay.
Cheat code.
Oh, wow. All right, anyway, I'm going to get too fiddled. So next section, reset, hit yes. In the next section, you're going to investigate mass. And if the mass has an effect on the problem. And you're going to notice, choose Skater at the top right. When you hit choose Skater, look at your options. You've got the Skater himself. You've got what's called the Star Skater, the Bulldog, the Bug, and the Ball. We're going to use the Bulldog, the Bug, and the Skater. So when you change to the Bulldog, and then close this, you'll see there's a Bulldog now on the skateboard. Okay? With less mass.
That's so cute. That's my favorite YouTube.
You're then going to answer the questions based on that. Okay, next. Go to the next one, please. Flip over the next page. Investigate energy. Again, hit reset. Hit yes. Click on the potential energy reference. Adjust the bottom and the PE equals 0 line to the 1 meter on the grid. So here's what I'm going to do. Watch. See this button right here, grid? You're going to hit grid next. And you see this grid line appear. And what this grid line does is provides me with height. 1 meter, 2 meters, 3, 4, 5, 6, etc. Okay, there's my grid. Now, adjust the bottom of the track. So watch what I'm going to do, everybody. Grab the bottom of the track right here and pull it down until it gets down here. So here's the bottom of the track, right? Here's the bottom of the track. I'm going to adjust it so that it's down here at 1 meter. Okay? Grid is right here on the right.
Go to the website.
Okay. Yeah, don't you shouldn't do that. Now, guys, if your simulation didn't load still, just pause. Stop trying to catch up. Just watch. Just watch. Okay, you can do it in a minute. Don't fall behind and then ask questions 3 sections prior to this. Now, what I also want you to do is adjust the potential energy line at the same height. So move this up so that they're both at the 1 meter mark, please. So again, this is under Investigate Energy on page 3 of your lab. Okay, we're on the 3rd page. So we took the bottom of the ramp, we moved the bottom of the ramp so that it was at the 1 meter height, and then we took the potential energy reference line and lined it up again. On the lower right,
My computer's literally too slow, so...
just watch for now. Guys, if your computer is not keeping up, just watch. Just watch. You're going to have 25 minutes to do this here, and then you can finish this at home if you need. Okay, I'm just going through the steps. On the bottom right, click Edit Skater. Down here, Edit Skater. And then it says you're going to have to scroll down to see the skater's mass. Change the mass to 100 kilograms. And you can just simply type 100, okay, as the mass. Hit Enter. Next.
This isn't until the third page though, right?
Okay, this is the third page. Next. Calculate the potential energy of a 100 kilogram skater at a height of 4 meters above the zero level. So, you have a mass of 100, a y value of 4, and g is 9.81. So use your formula from class. P equals mgy. Take your mass of 100 times 9.81 times 4 to calculate the potential energy and fill it in that blank. Okay, that's number 14. That's number 14 I'm referring to. Now, after that, click on the energy graphs, but hit energy versus time. Not bar graph anymore, but energy versus time. Okay? Now, it might be useful to take the energy versus time graph and just slightly move it upward so that it doesn't cover the skater himself. Okay? I don't even know what you're asking. What? No. That was a calculation. Read number 14. It says calculate. You're not actually doing that yet.
Oh, well then how would we put forward? Where would we type that in?
You're not typing it in. You're calculating it. Remember P equals mgy?
Oh, yeah.
You're calculating it. 4 is y. Alright, so we're going to return the skater and use a record function now. Alright? So, first,
Oh, wait, how did you get that up there?
I pressed the button that I told you to press about 20 seconds ago, which said energy versus time over here on the right. Alright, so watch what happens. First of all, I'm going to hit return skater first. Skater's going to drop on there. He's going to be just floating back and forth. Now, here's what I want you to notice. When we hit the button go here, it's going to start tracking the energy as a graph. Okay, so when I hit go, why is that not? Ah, sorry. Return skater.
Wait, it was just working for me.
Give me a sec, guys. It's glitching. Hold on.
Oh, press clear. Press clear. And then press go. Oh, it works for me.
There we go. All right. So,
Thank you, Molly.
take a look now. Take a look.
Say Apple Genius bar.
We clear it first. Thanks, Molly. Clear it.
You're welcome.
Then we're going to hit go. And then we're going to hit return skater. Again, this is all being recorded. So if you don't get any of this, guys, and you want to work on it later tonight or something, it's all being recorded. Now, what's happening?
Why is yours going so fast and mine's going so slow?
Maybe your speed is slower. You have your speed on fast. You start them up here. I don't know. Keep fiddling. It'll work. Now, here's what we're going to notice. We're going to see that the speed and the energy, okay? So I'm going to hit stop now. Pause. Thank you. All right. We're going to see this constant fluctuation. We're going to see that the... Where's my key? I want to have a key on here. Ah, here we go. Okay. Look at your font. The blue is potential energy. The green is kinetic. The yellow is the total. The red is the thermal energy lost. Now, there is no friction on here, but the program automatically defaults to a low value of thermal energy. So you're going to see that number 206 there. Okay, you can ignore it for the time being. Okay? Sorry? It's not going to because it's not changing. It's saying we lost energy in the very beginning, and it's not losing energy afterwards. So take my word, ignore it for now, okay? Now, what I want you to do, okay, and by the way, this button says go here. The lab, it says record. This is a new version of the program. Okay, when I wrote this lab, it said record still. I got the new version the other day, and it says go. So go and record. Okay, I think of them as the same thing. Now, take a look at this button here that says step. What step is going to do is going to allow me, once I clear this, yes, clear, go. All right. Watch. If I pause this for a second or hit stop, and I use the step command, watch what happens. Look at the skater. Everybody seeing what's happening here? What's it doing?
Oh, it's frame.
Yeah, it's freeze framing. Now, there's going to be a point in time it says, use the rewind and step function to record the potential and kinetic energy at various positions in the table. So take a look at the first column. At point 1, about 4 meters level going down. So let's take a look. Here's 4 meters, watch. Here's 4 meters, but that's going up. So he's going to go up, go up, go up, go up, go up. And he's going to start coming back down until we get to right there, about 4 meters. So I use the step command to get the skater to pause at 4 meters on the way down. And now look, we have our values here. They're all written in the data table. So you're simply going to plug in those 3 numbers. Is that clear? Again, now, here's what I want you to notice, please. Please think about this. The potential and kinetic energy are going to sum up to some value. It should be the total energy. Why won't that be the same? What is the program accounting for in the beginning that I said? What's the thing I said to ignore? Max? What was the thing I said to ignore? Yeah, the thermal energy at the top here, okay? I said ignore that. So what you're going to notice is this. If you add these 2 numbers together, you're not going to get exactly the total here. So if you look at your data table, you're going to see kinetic, potential, and then total. Again, I'm pointing on my sheet right here. If you look up, kinetic, potential, and total. Feel free to just add these 2 numbers together to get the total energy. You don't have to write down what you see in the yellow there, because it's not going to be the exact same number.
Before I pressed clear heat, and now thermal energy 0.
Oh, thanks, Molly. Let's try that. So let's go to clear heat on the right. Hit clear heat, and then clear this out and restart it. Nice, Molly. Good work. All right. So let's say before, see? Awesome. I appreciate that. Before we start this kind of a problem, or this end problem here, where we're using this energy versus time graph, hit on the right here, clear heat on the very right, then hit clear again, and then hit go. Okay, hit go, and then we're going to pause him here, and then we're going to use our step command to get down to 4 meters. When he's down to 4 meters right there, now we'll see it does make sense. Thank you, Molly. Well done. Okay. Again, potential and kinetic summed together will give us the total amount of energy.
My graph crashed.
What's that?
My graph crashed.
Your graph crash.
Yeah, so
What did I just
I'm just closing it. What about energy versus time? Your go works?
Is there a baby filter here?
it's just
Right click on the graph itself, see the options.
Java.
I'll let
Okay,
them-
this is Java.
No way.
This is skater speed. We just say normal so fast or
Yeah.
is that
you
like
use
No.
oh, there's not like a number.
Read what it says in parentheses. Right to left. Judge the
Just we're going like speed.
relative means comparing each other,
All right.
not numerical. All right. The last part is to choose a bug. Okay. So while the energy graph is still showing, choose the bug. Hit close. Now, watch what we're going to have to do. We're going to have to enlarge this graph because the energy of the bug is going to be so small that if we try and do this, if I hit go now, watch what will happen. If I don't enlarge it, if I just hit go, we're going to see where's my energy. See how it's like non-existent? It's because we're not zoomed in enough. If I hit plus, watch what happens. Look at my y-axis. I'm getting zoomed in further. And now if I hit go, now I can see there's still some of the energy there of the bug. I got to zoom in even further and further until I can actually start seeing that there is energy of the bug. But what do you notice about the energy of the bug? It's on a much smaller scale. We're talking about only numbers like 8 and 0.6 for joules as opposed to the object or the skater. Why does the skater have more energy? Because he has more mass. Okay? Last thing, investigate height at the bottom. All right, so pause everything, hit reset, We're going to use this reset button a lot. Hit yes. Click show grid, or grid on the right. So we have the grid going. Adjust the ends of the track up to the 11-meter level and the bottom down to 1. So here, grab this end, move it straight up to 11. Take this end, move it up to 11. Take this end, drop it down to 1. And by the way, actually that's fine. What do you mean? Grab the end of here.
No, I can't see like the
Right down here, zoom in and out. Maybe zoom down or zoom in a little.
Oh, I got it.
Got it? All right. So pause it. Pick up the skater. Move the skater to the top of the track. Okay? And then hit play. Now, what you're going to notice, okay, what you're going to really try and notice is the difference. Earlier, remember he was going pretty slow at the very bottom? Now how fast is this guy going? A lot faster. Why?
He's getting more energy.
Yeah, he's picking up more energy on the way down. And the potential energy at the top now is much higher, isn't it? He's got potential energy not at a height of 4, but at a height of 11. So now his potential energy at the top converts all to kinetic energy at the bottom. And what we're going to see is we can see that, if you'd like to see that again, on our bar graph. Look at our energy now. I'm going to clearly have to zoom out a little bit so I can see our energy totals. If I were to use my energy versus time graph, and I zoom out, okay, look how much more energy there is now. There's 8,000 joules of energy here. The last time we did it, it was something around like 3,900 or 4,000 because we started the object or the skater from a higher elevation. So your goal for obviously today and tonight, okay, your goal is to finish at least through that end of that page. Now, on the next page, you're going to see discussion problems. Hold off on those if you'd like to. If you want to get a head start, listen carefully, look at section 5.3 in your book. If you have some time over break and you want to get a head start and get ahead, which you all should do really, but it's up to you, take a look at section 5.3, read that, and attempt at least the last page. But we're still going to go over section 5.3 in class next week, where in class it might help you understand it a little bit more. Any questions? There's a lot going on in this lab. That's why I spent all that time just now doing it. You have 15 minutes left in this period. If you don't finish, don't worry. Just go online and use the same site. Okay, it's phet.colorado.edu. Definitely through the first 3 pages. Complete everything through the first 3. Everything. The 4th page is up to you to get a head start on using section 5.3. Okay? You could still, well, seriously, actually, you could do 1, 2, 3, and 4 on the last page right now, too. Maybe 5, 6, 7 might be tougher, but it's not that tough.
Maybe this would be better